morning, everyone. I am Laila Q. Isen, your teacher for today. Welcome to our mathematics class. I hope that everybody is doing good. Before we start, make sure you have with you your notebook, your ball pen, your calculator, and your module. For today's episode, we will talk about arithmetic series. These are our learning objectives. At the end of the lesson, you should be able to A. Define arithmetic series. B. Find the sum of the first n terms of an arithmetic sequence. And C. Solve word problems that involves arithmetic series. To start with, I will give you a problem to solve. I hope that you are ready with your paper and your pen. You only have 1 minute to answer this problem, and you are not allowed to use your calculator or any computing devices. You are only to use your paper and your pen. Are you ready? This is the problem. Find the sum of the first 100 positive integers in 1 minute. Go! Time's up. Were you able to get the sum? If yes, how did you do it? There is a popular story about how young Carl Friedrich Gauss, a great mathematician, solved an arithmetic series faster than anyone else in his class. When Gauss was 7 years old, his teacher asked him to solve the sum of all the integers from 1 to 100. This question is to keep him busy. However, in less than 1 minute, Gauss was able to solve the problem correctly. His teacher could only look at him in astounded silence. Now, how did Gauss solve this problem quickly? I will show you. Let's think of all the digits drawn out in a long row of end to end. On the far left is 1, and the far right is 100. If we add the first and the last term in the sequence, we get a sum of 101. If we look one step in from these numbers to 2 and 99 and add them together, we also get 101. Move to another pair of numbers, 3 and 98. They also have a sum of 101. This pattern continues throughout the sequence of numbers until the last pair, which is 50 and 51. Looking at the sequence, there are 50 pairs of integers that give a sum of 101. Multiplying 50 and 101 gives us the sum of all the positive integers from 1 to 100. That is 5,050. Were you amazed? Don't worry if you were not able to find the sum right away, because for today, I will be showing you formulas how to solve for the sum of the first n terms of an arithmetic sequence. The sum of the first n terms of an arithmetic sequence is called the nth partial sum or finite arithmetic series, and it is denoted by S sub n. There are two formulas that we will be using. If the first term and the last term are given, we will use S sub n is equal to n over 2 times the quantity a sub 1 plus a sub n. If the last term is not given, we will use S sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times d, where a sub 1 is the first term, a sub n is the nth term, or usually the last term, in a finite arithmetic sequence. D stands for the common difference. N is the number of terms in a given sequence, and S sub n is the sum of the first n terms. Let's have example number 1. Example number 1. Find the sum of the first 31 terms in the arithmetic sequence 28, 17, 6, -5, and so on. First, let us identify the given. Let's start with the first term, a sub 1, which is 28. Next is the value of d. We can get this by subtracting any two consecutive terms, like 17 minus 28, or 6 minus 17, or -5 minus 6, which gives us -11. Next is the value of n. Since we are to solve for the sum of the first 31 terms, then our n is 31. We can now solve this problem using this formula. We can now replace all the variables by the given values. So, a sub 1 will be 28. All n will be 31. And d will be -11. Let us simplify. 31 divided by 2 is 15.5. 2 times 28 is 56. 31 minus 1 is 30. Then multiply 30 times -11 is -330. Continue simplifying. 56 minus 330 is equal to -274. 15.5 times -274 is equal to -4,247. Therefore, the sum of the first 31 terms of the arithmetic sequence is -4,247. I hope that you were able to understand example number 1. If not, you may ask help from your parents or your older brothers and sisters or friends. Let's have another one. Find the sum of all positive even integers less than 50. So, what is the first positive even integer less than 50? It's 2. Then, add the next even integers, which are 4 plus 6 plus 8 and so on until the last even integer less than 50. And what is that? (48). Since the first term and the last term are given, we can use this formula. Now, let us identify the given. The first term, a sub 1, is 2. The last term, a sub n, is 48. How many even integers are there from 2 to 48? (24). Therefore, the value of n is 24. Let us now substitute the given values to the formula. We will replace all the variables with the given values. So, we have s sub 24 is equal to 24 over 2 times the quantity 2 plus 48. Then, simplify the equation. 24 divided by 2 is 12. Then, 2 plus 48 is 50. 12 times 50 is 600. Therefore, the sum of all positive even integers less than 50 is 600. Again, I hope that you were able to understand example number 2. This time, for example number 3, we will apply the concept of arithmetic series in solving word problems. Let's have example number 3. A family wanted to buy a new set of personal computer at the end of the year. So they saved 600 pesos in January, 800 pesos in February, 1,000 pesos in March, and so on. How much will they save in 1 year? To compute how much will they save in 1 year, we will add their savings every month. So, we have 600 from January, plus 800 from February, plus 1,000 from March, and so on until the 12th term, since there are 12 months in a year. Looking at the series, it is the sum of an arithmetic sequence whose common difference is 200. Therefore, we can use this formula to solve for the sum. Let us identify the other given. The first term is 600 and n is 12. Let us substitute. So, we have s sub 12 is equal to 12 over 2 times the quantity 2 times 600 plus the quantity 12 minus 1 times 200. Let's continue simplifying. 12 divided by 2 is 6. 2 times 600 is 1,200. 12 minus 1 is 11. And 11 times 200 is 2,200. Simplifying further, we have 1,200 plus 2,200 is equal to 3,400. And 3,400 times 6 is 20,400. Therefore, the family will save 20,400 pesos in 1 year. So that ends our discussion for today. Let us sum up the lesson. If you want to practice more on finding the sum of the first n terms of an arithmetic sequence, you may answer the activities found in your module number 2. See you next time.